Hi, my name is Clay, and my presentation is on naloxone as an effector of glycogen phosphorylase B. Now, glycogen phosphorylase is an enzyme which converts glycogen to glucose 1 phosphate, which is later converted to glucose 6 phosphate. Now, glucose 6 phosphate is important to metabolic pathways such as glycolysis, and glucose 6 phosphate can also be converted to um, blood glucose, which is important for blood sugar homeostasis. Glycogen phosphorylase has two active forms, glycogen phosphorylase A and glycogen phosphorylase B. My following experiments were conducted on glycogen phosphorylase B. Now, Narcan is a life-saving medication which acts as an inhibitor to opiates and can end an overdose when administered properly. Naloxone is the chemical name for Narcan. Um, In this study, multiple assays were conducted, and these assays measured the activity of glycogen phosphorylase. A higher absorbance is a higher activity of glycogen phosphorylase. In my first experiment, we created a calibration curve of inorganic phosphate. As inorganic phosphate is integral to the activity of glycogen phosphorylase, so it was assumed that as more phosphate was in solution, we would see a higher absorbance, which is what we found. A second experiment was done, and this was an assay over AMP. AMP is a known activator of glycogen phosphorylase. So the hypothesis with this experiment was that as more AMP was in solution, we would see higher activity of glycogen phosphorylase. For this experiment, we had six assays, and that first assay was just a control. So there was no AMP, no enzyme that had the lowest Vmax out of all. Um, and the lowest and the highest KM, like comparatively. So that means it was the lowest trial. As AMP was increased, we saw a increased activation of glycogen phosphorylase B, and because of that, we can determine that it was a activator in this experiment. Now, my second experiment was over epinephrine and is very similar to how it was conducted, except there was no control this time, other than just that there was zero epinephrine in the experiment. We saw that as epinephrine was increased, we saw an increased activation of glycogen phosphorylase B, which is what was assumed to have happened based on known behaviors beforehand. The final experiment that I did was over Narcan as an effector of glycogen phosphorylase B. Now, Narcan is a inhibitor of uh, opiate receptors in the brain, so I assumed there would be no change in activity. That my hypothesis was that there would be like it would just be the same for all trials, and that is not what we found. Now, because naloxone has not been studied previously, as far as I know, over glycogen phosphorylase B, I conducted the experiment to test as both an inhibitor and activator. And all that really means is that there was a change in AMP concentration. The inhibitor trials had higher AMP concentration, and the activator trials had lower AMP concentration. So when we tested Narcan as an activator, it was seen to be as an activator, it was seen to have actually activate as a mixed inhibitor. So at low AMP concentrations, saw mixed inhibition activity, and at high AMP concentrations, we saw activator activity, which is very unusual. And given that there is only one repetition of this experiment done, for my future directions, I would like to test this experiment more, try it at different concentrations, and then see like multiple iterations to see if this is actually the activity, because that would be very novel if it was. The second thing I would like to test is HCl's activity on glycogen phosphorylase B. Now, Narcan has HCl in it. That's the inactive ingredient. And it may be that HCl is what is leading to this activity. I would like to acknowledge my professor, Dr. De Guzman. He was very helpful in helping me set up this experiment. Same with my TA, Alfred. He was really great at directing us through this. And then my lab partner, Tasir, he helped me with the calibration curve and the AMP assays. We both did that together. And then the epinephrine and Narcan was me specifically. Thank you.